Hello! Welcome to today's lesson on radioactivity. Today, we will understand activity as a measure of how many unstable atoms in a radioactive sample are decaying per second. Then, we will understand count rate as a separate measure of the number of radiation particles detected by a detector. Finally, we will investigate some of the applications of these measures in real-life scenarios. So far, we have explored the concept of radioactivity and its random nature. We've discussed how certain atomic nuclei are unstable and tend to decay, releasing radiation in the process. Building on this foundation, we can now introduce the concepts of activity and count rate. These new ideas will advance our understanding of physics by allowing us to quantify and measure the decay processes of radioactive substances and understand their practical applications more thoroughly. Activity is a measure of how many unstable atoms in a radioactive sample are decaying per second. To give a more relatable analogy, imagine you're making popcorn in a microwave. Each kernel that pops represents an atom decaying. The more kernels that pop per second, the higher the activity. The unit of activity is the becquerel. 1 becquerel is defined as 1 decay per second. So, if you have 1 becquerel of a radioactive substance, it means that on average, 1 atom is decaying per second, much like observing 1 popcorn kernel popping every second. Just like the rate of popping popcorn gives you an idea of how quickly all kernels are popping, the activity gives scientists an idea about the speed at which the radioactive decay is occurring. Different radioactive samples can have different levels of activity, depending on how many unstable atoms they contain and how fast those atoms decay. A sample with more unstable atoms or a faster decay rate will have a higher activity. While activity measures the total decays happening in a sample, count rate measures the number of radiation particles detected by a detector. Imagine you're in the kitchen listening to the popcorn pop. The sound of each pop you hear is like the count rate. It represents the number of decays that are actually detected by your ears, or in the case of radiation, by the detector. The count rate is usually given in counts per minute, CPM, although it can also be in counts per second, CPS. It reflects how many particles a detector, like a Geiger-Müller tube, picks up in a specified time. If activity is the total number of kernels popping, then count rate is how many of those pops you actually hear, which might be fewer than the total pops depending on how close you are or how good your hearing is. The count rate can be affected by several factors, just as how well you hear the popcorn popping can depend on where you're standing or if there's any noise in the background. One of these factors is detector efficiency. Different detectors have varying abilities to detect radiation. Some are more sensitive and pick up more decays, just like some people have better hearing for those popcorn pops. Another factor is distance and shielding. The closer the detector is to the radioactive source, the higher the count rate. If you move farther away or put something in between, like a wall or a shield, the count rate drops. It's similar to how the sound of popping kernels gets quieter the further you are from the microwave, or if there's a door closed between you. A final factor that affects count rate is the type of radiation. Not all types of radiation are detected equally. Alpha, beta, and gamma radiation interact differently with detectors, much like how some popcorn kernels may make a louder sound depending on their size and type. There are many applications of these measures in real-life scenarios. In nuclear power plants, monitoring both the activity of radioactive fuel and the count rate of emissions ensures reactor safety and functionality. High activity levels could signal instabilities, requiring careful management to prevent accidents. In medical diagnostics, radioactive isotopes are used in imaging, needing precise measurements of activity to ensure accurate dosages. The count rate helps in detecting the isotope's emissions to form images of organs. For environmental monitoring, detecting radioactive contamination involves measuring activity in various samples and using count rates to assess the spread and intensity of radioactive emissions. Accurate measurements help in risk assessments and remediation efforts. By understanding both the activity and count rate, you'll appreciate how scientists measure and interpret radioactivity. These concepts are foundational to fields like nuclear physics, health sciences, and environmental studies, highlighting the importance of precise measurement and monitoring of radioactive materials. In today's lesson, we delved into the concepts of activity and count rate within the realm of radioactive decay. We learned that activity measures the number of unstable atoms decaying per second in a radioactive sample, with the unit of measurement being the bequerel. This gives us a sense of the overall rate of decay processes occurring. In contrast, count rate is the number of radiation particles detected by a device, often expressed in counts per minute. By understanding activity and count rate, we gain insight into how radiation is measured and monitored, which is essential for various scientific and medical applications.